All right, so let's make a video about all the calculus topics you need to know for the AP Calculus exam. Topic number 1, limits. Remember, the basic definition of a limit is basically fill in the pattern. What does it look like the function is going towards? In order for a limit to exist, the limit from the left must be equal to the limit from the right. And if that is true, the limit of the function as x goes to some value is the left and right hand side limit together. Should you come across a limit that comes out to indeterminate, meaning 0 over 0 or infinity over infinity, when you use substitution, L'Hopital's rule is a great way to simplify the problem. This often happens with rational functions, because we get 0 over 0 or infinity over infinity when we have a fraction. By using L'Hopital's rule, the limit of the rational function whose limit in substitution is indeterminate is equal to the limit of the derivative of the top divided by the derivative of the bottom. So you basically take the derivative of the top and bottom separately and then try substitution again. You would continue this process of taking the derivative of the numerator separately from the denominator until you can get a value when substituting. Limits help us determine if a function is continuous. And that only occurs when the limit from the left-hand side of that x value equals the limit from the right-hand side of that x value, therefore showing that the actual limit exists, and that limit is equal to the actual function value. So this basically on a graph looks like the limit from the left-hand side of our x value of a equals the limit from the right-hand side of our x value of a equals the point of our x value of a. There are technically 4 types of discontinuity. We have removable discontinuity where the point itself doesn't actually exist, but everything else does. We have a second type of removable discontinuity where that point that was removed is somewhere else that does not follow the trend of the graph. Another type of discontinuity is called jump discontinuity, where if we follow the graph, every x value has a y value. However, there's one point where in order to get from one y value to the next, we have to literally jump down or up on the graph. And the last type of discontinuity is infinite discontinuity, where we have a vertical asymptote. The intermediate value theorem states that if a function is continuous on a closed interval, then there exists some x value c in between that closed interval where the y value is somewhere in between the y values of f of a and f of b. It basically means that if we know the y value at x equals a and we know the y value at x equals b, then the continuous function must also hit every y value in between those x values. It doesn't necessarily mean that the function goes from a straight to b. The function could actually do a lot of stuff in between. But we know for certain that if a is this low and b is this high, that at every point in between x equals a and x equals b must also have a y value somewhere in between those y values. When you're asked a problem like this on the AP test, it will give you the function f of x and ask you to prove that f is equal to some y value at some point on the interval a to b. So basically, it's asking you to prove something about the function itself that's given. A function is differentiable if it is continuous and smooth. Again, a function is continuous if the limit from the left-hand side equals the limit from the right-hand side, therefore equals the limit, which is the actual function value. A function is smooth if its derivative also has a limit. A question you'll often get is a piecewise function where they ask you, does the derivative exist at that point where the two pieces meet? The first thing you need to check is that the function is continuous, because a function cannot be differentiable if it is not continuous. And the second thing you need to check is that the function is smooth. So you basically want to take the derivative of each of the pieces on your piecewise function and make sure that the derivative of that x value from the left is equal to the derivative of that x value from the right-hand side. When I say a differentiable function needs to be smooth, it has a smooth transition from one x value to the next, meaning the slope is not a drastic change. There are 4 types of ways where a function can be non-differentiable. First off, you can have any of the discontinuities. A corner is a drastic change from one direction to another. A cusp is an even more drastic change from one direction to another. And a vertical tangent occurs when the slope is undefined. A derivative is just the instantaneous rate of change, or the slope at a particular point. The definition of a derivative comes from the average slope formula using limits. So it's basically saying the slope between 2 points where the limit of the distance between the 2 points becomes 0. So basically it's the distance between one point in itself. The derivative is often confused with average slope, which is just the slope formula from Algebra 1. Now, if you're seeing a free response problem that's asking you to estimate the derivative at a particular x value, that's basically asking you to use the average slope formula in order to find a possible value for the derivative. Again, if you see the word estimate, that's a clear indicator because this is the average slope formula, whereas the derivative is supposed to be instantaneous. So an estimate is all that we can get from this formula. You will often be asked to find the tangent line of a function. A line that is tangent touches the curve of your function only once. And this occurs because the slope of the tangent line is equal to the derivative of the function at the point of tangibility. And the point of tangibility is the point that will be in your tangent line. The easiest way to write a tangent line is to use point-slope form because you will often be given the point and you'll find the slope. Luckily, with an AP test, you won't need to rewrite this into slope-intercept form. With the information given, it looks like this. Sometimes you'll be asked to find the linearization of the function, which is simply just the tangent line. You may also be asked to approximate the value of the function itself at any particular x value that's very close to the one used in your tangent line. And all that's asking you to do is plug in that x value that they're giving you into your tangent line. The idea is that a function is locally linear. So if you were to zoom in on a particular x value, as far as you can go, you'd find that it looks linear as if you go in really far. Which means that a tangent line is good for approximating those y values of your function that are pretty close to your tangent point. The mean value theorem states that if f is continuous on the closed interval and differentiable on the open interval, then there must be some point in between that interval where the average slope is equal to the instantaneous slope. Oftentimes in a free response problem, you'll be given a function that is identified as differentiable. And remember, if a function is differentiable, then it is therefore continuous. And they would basically ask you to prove that there exists some x value where the derivative is equal to, let's say, 5. So all you would need to do is, on that interval a to b, find the average slope, and hopefully it comes out to 5. If it doesn't, then you need to try a different theorem. When you're answering a problem for mean value theorem, make sure that you're applying it to the actual problem and not just stating the definition of the theorem. So when you're answering the problem, you want to make sure that you find that average slope, so you're applying it to the problem itself and not just restating the definition. So find that average slope and prove that the average slope is equal to a particular value, which means that since the mean value theorem applies, the derivative must also equal that value. You'll often see this problem when they give you a function f of x and ask you to verify whether or not the derivative is equal to a particular value. So it's asking you to calculate the derivative. An integral is simply the area between the curve and the x-axis. Keep in mind that when you're using this definition to find an integral, that anytime the curve is above the x-axis, the area is positive, and anytime the curve is below the x-axis, the area is negative. Think of it as the height. If the height goes up, that's a positive value for h. If the height goes down, that's a negative value for h. Keep in mind that the integral itself is just the net change in distance, so you're basically comparing the starting point to the ending point and not looking at what's happening in between. If you're looking to find the total distance traveled by an object, you would need to take the integral of the absolute value of the function, which basically means that any positive distance and any negative distance would just be counted as distance instead of taking away from each other. To find the actual position of an object from its derivative, you would need to have an initial condition. And in order to set that up, you would say the y value of your initial condition is the initial position, and then we integrate starting from that x value of the initial position and go up to our final position that we're looking for. An application of integrals is the average value of a function. The formula for this, for an average value of a function f of x over an interval a to b, is 1 over b minus a, the integral from a to b of the function. If you think about averages, it requires that you add everything up and then divide by how many there are. The adding everything up is taken over by the integral here, and then dividing by how many there are is the 1 over b minus a. This is the distance between b and a. In the past, AP tests have asked you to find the Riemann sum of a function and then give the value of this as an integral and explain what it means. So anytime you see a fraction in front of your integral, that often means average value. And you can verify this by the fact that if you're going from a to b and the distance between those two is this number down here. Sometimes AP testers will confuse average value with average slope. What you want to look for is what the question is asking you to do. Are you finding the average of the function that's given to you? That would be average value. If you're finding the average of the derivative of the function, that would be the average slope.